You are cordially welcome to our online platform Step Up Bengal for the next lecture, that means lecture number 18. Up to this, we have discussed lecture number 1 to 17 on classical mechanics. In the last lecture, that means in lecture number 17, we have discussed about Hamiltonian formulation, that means formulation of H. And we have discussed a question of CSIR net 2018 3 mark question. In that same question paper, we have also a 4.75 mark question which is dependent on Lagrangian to Hamiltonian conversion. Again, the question is very much similar. Here H is given, look at the beauty. Here H is given to be P square by 2m plus K by 2 into Q square type. This is our age, and they have spoken about just to solve us, and they have given to solve what will be corresponding Lagrangian. Now in the previous lecture, that means lecture number 17, I have given to you a very shortcut tricks about Hamiltonian to Lagrangian conversion. Here we will apply that trick to solve this question very quickly, and for that we will just go through options. Say this is, if possible, this L is our Lagrangian. So just write down that L equal to half into mq dot square minus k by 2 into q square. This is our kinetic energy part. So half into mass into velocity type, as I have said in lecture number 17. Just revisit the lecture and you will get the shortcut tricks. Mass into velocity, and this is obviously potential energy V, which is free from time, free from t, or velocity. What is that velocity? That means q dot. I have already said you, they have in general given to us only one or two coordinates. Here generalized coordinate is only one, so q is there. So what will be corresponding Hamiltonian? If this is the Lagrangian, then what will be corresponding Hamiltonian? That will be p square by 2 into that mass, 2 into mass format, and potential energy will be just reversed. Here potential energy is given in negative sign, so that should be plus sign, k by 2 into q square. And this is, what is that mass? Mass is p square by 2 into, what is that mass? That mass is m, so p square by 2m plus k by 2 into q square. Now we will see if this is the Hamiltonian given. Yes, p square by 2m plus k by 2 into q square. So obviously this is the answer 1. Now the beauty is that when this particular question was set, most of the students answered only 1, because they somehow missed the trick of gas transformation, which I have just discussed in a previous lecture, perhaps lecture number 16. What is the beauty? 15 or 16, you should visit. What is gas transformation? By gas transformation, L is not unique. L is not unique. We have discovered L. So is this our L? No. So option number 3 is eliminated. If 3 is eliminated, look at the beauty. 4 half mq square plus sign, but we should have minus sign, so this is also eliminated. Now the only thing remaining to do will be this option number 2. Now we have to just see if gas transformation is applicable to this. If this is applicable, then that will be also the answer, because it is 4.75 mark question, that means multiple select question. Now let us see it. In the second option, half mq square minus k by 2, if we just take this second option, what will be our L? In the second option, what will be our L? L will be just break this part. Half into mq dot square, minus k by 2 into q square. This is our Lagrangian, because from this Lagrangian we have arrived at our Hamiltonian given above, this one. So this is obviously Lagrangian. This part is Lagrangian. The second part was any new L dash coming from this L will also be a Lagrangian by gas transformation, if this L dash can be written as this portion is L, and finally we have seen that this should be df by dt type, where f should be and must be some function of time and coordinate. Now, can we make this as time and coordinate type, this second quantity? That means the quantity here was minus of k by 2 into 3q square q dot. Can we make it just comparable to this? Yes. See here, our L dash is half into mq dot square minus k by 2 q square, and we can make the second part as minus, we should take that minus sign also inside, minus k by 2 q cube, because if we just break this quantity, what we will have? Minus k by 2 into 3 into q square into q dot. This should be in the last expression. Is it there? Yes. Minus k by 2 3q square q dot. We have already arrived at that. So the second option by Gauss transformation will also be true. So its final answer will be 1 and 2 by Gauss transformation. So we have seen that in the question of CSIR, whenever a 4.75 mark question is given, please go through all the options carefully, because it may be so that apparently it looks that only one is correct, but some other concept may be inserted, such as Gauss transformation. And I have previously told you that as in real analysis or complex analysis or linear algebra, any topic of CSIR net, in every question almost there are 3 ideas, 2 to 3 ideas inserted. Often we see 4 ideas also. 4 ideas also. Here 2 ideas are inserted. One is Lagrangian to Hamiltonian conversion, and second is Gauss transformation. So if you just go through all the aspects carefully, then you can solve all the problems within very short amount of time. But these tricks discussed in lecture number 17, this particular transformation from H to L or from L to H, is extremely critical. This p square by 2 into mass factor and reversed sign as potential energy. So we hope that all of you have clear idea why in the final answer key they have given 1 and 2 as correct answers. So for this video, goodbye.